get familiar. So if you don't know by now, then you should probably get familiar.
So welcome back, students. So in this video, I'm just discussing whatever the things we left out in the last videos. Okay, some of the concepts we have to continue from the last video. So that is actually about the total reaction. Okay, so in the last video actually what we have discussed is about the two types of frictions, that is static friction and kinetic friction, and similarly how to calculate the coefficient of static friction and coefficient of kinetic friction also, right? Now let us see the relation between the normal reaction and limiting friction. So because the basic cause for any friction is normal reaction and the maximum static friction is called limiting friction, right? So now if you consider the resultant force of normal reaction and the limiting frictional force, so that is called actually the total reaction. So you can write the total reaction as RT is equal to N plus Fs maximum. So what is Fs maximum? So this is called actually normal reaction. Clear? So this is another concept, you will get the total reaction. Okay, now let us see some experimental observations for the coefficient of static friction and coefficient of kinetic friction here. Okay, so coefficient of friction in general, either it may be μs and μk. μs is actually coefficient of static friction and the second one is coefficient of kinetic friction. So that values depends upon the type of materials. Okay, so whether you keep a metal on a wood material or a metal on another metal or a glass on a metal, etc. So depending upon that, you will experience the frictional force between the two surfaces in contact, isn't it? See, a few of the examples I mentioned here. Just go through that. Steel on steel. So you have to assume that there is a steel material and over that another steel block is kept on it and then you are trying to pull it and a frictional force is created between the two surfaces in contact. So what is the coefficient of that static friction or coefficient of kinetic friction? So experimental observation is, so for steel on a steel, μs coefficient of static friction is 0.74 whereas μk is equal to 0.57. You just observe that here coefficient of static friction is little bit greater than coefficient of kinetic friction. Why? Because when the body is at rest, okay, initially when it is at rest, what is the friction? It is actually 0. But friction is self-adjusting force, isn't it? As you apply the force on the body to pull it, then it increases from 0 to the maximum. Till then it is called the static friction only, isn't it? So value of that will be greater. Once it starts moving, the frictional force reduces and hence corresponding coefficient of kinetic friction also reduces, and hence we have μs is 0.74, okay, μk is 0.57. So μk is less than μs. Okay. Similarly, copper, a metal kept on a glass surface. It is observed that μs is 0.68, μk is 0.53. Okay, glass on a glass. See, the value of μs is 0.94, okay, μk is equal to 0.40. See, particularly this value, I can mention that it is a greater value. Why? Because you think that glass is very smooth surface. Of course, it is smooth for other materials. Okay, it is not having much friction if you keep the other material, and if you try to observe the friction, it may be less. But if you keep another glass on the glass surface, it is not that easy to pull, okay, because of the smooth surface itself, okay, interlocking between the atomic molecules, okay, will be more, so they will not allow the body to move easily, okay, the friction is very high, so μs is 0.94, okay, once it starts moving, of course, it reduces, frictional force reduces, that is why μk is equal to 0.40. Similarly, metal on a metal, but here the particularly you take any metal, but if it is lubricated, means what? In between the two surfaces, some lubrication is applied like grease, wax, etc. Okay, so then it is lubricated. So you will see that value of frictions reduces to 0.15 or 0.06. Similarly, Teflon material kept on steel, 0.04. Teflon is a very light material, okay, lightweight material. So when you keep it on a steel material, easily it is pulled. That is why the value of μs is almost 0.04 for both. Then ice on ice, Okay, ice of course you can say very smooth surface compared to glass. Okay, and ice block, over that another ice block easily skids. Okay, skidding effect is more, and hence the mu s value is mu 0.10. Okay, the sliding effect is also very easy, so mu k is equal to 0.03. Wood on wood 0.25 to 0.50, it may vary depending upon type of wood, of course you can say. The mu k is equal to nearly 0.20, like that. So we can just try to understand what is the difference between static friction and kinetic friction. Clear? Okay, finally just note down these important points also. See, the value of mu in all the cases, right? Value of mu is either it may be mu s or mu k, is always less than 1. See, all are fractions. Okay, it is always less than 1 for all materials. Okay, then coefficient of friction, so mu has no unit. We have to just mention only the values, no unit for that. And similarly, coefficient of friction mu is always dimensionless also. Clear? So these are all about the important points to be noted about the friction. Okay, then I will see you in the next video with a new concept. Thank you for watching.